gonna take a wild guess and say you've probably used the phone. And I bet you've enjoyed the benefits of a little thing we call air conditioning. You know who made those things possible? Engineers. We were just talking about engineers in our last video, people who design and build things to solve problems, and there are lots of different kinds of engineers. No matter what type of engineer you want to be though, civil, mechanical, electrical, or a kind that doesn't even exist yet, there's a series of steps that all engineers follow when they're trying to solve a problem. This process is called, wait for it, the engineering process. Makes sense to me. So what sort of steps are included in the engineering process, and why do we need it? Let's go through it step by step and discover how awesome things are made. First thing you gotta do is just define the problem. I mean, before you can solve a problem, you have to figure out what it is, right? For example, back in the 1800s, an engineer named Alexander Graham Bell was trying to come up with a simpler, cheaper way for people to communicate. Back then, the best you could do was a telegraph, which was an old-fashioned system of sending messages over electrical wires. Bell identified his problem. Communicating with people who were far away was expensive and took a lot of time. So his invention, or solution to this problem, was something you may have heard of: the telephone. Nice. Now, once you've figured out what problem you want to tackle, you need to do your research. You can start by just making a list of questions you have and what information you need to start answering them. You can also look around and find what other things already exist that have tried to solve this same problem. Maybe they can be improved. A good example here is the man who helped us blow stuff up. The chemist and engineer Alfred Nobel invented the explosive known as dynamite, not because he particularly enjoyed explosions, but because miners and other people who, well, needed to blow stuff up to do their jobs needed an explosive that was safer to use. So before he started on that problem, Nobel did research to see what explosives already existed, which ones worked well and which ones didn't. This takes us to step 3. Develop a solution. After your research is done, this is where you say exactly how you think you can solve the problem. And once you've thought of a good solution, you have to figure out how it'll actually work and what it will look like. So you have to design your solution. This is where you get to draw. Civil engineers always sketch out their ideas, like buildings and bridges and towers, to show what they'll look like when they're done. Gustave Eiffel designed the famous Eiffel Tower in France, and he definitely showed up on day 1 of construction knowing exactly what it was gonna look like. On to step 5, build a prototype. A prototype is just a simple model that lets you test out your design. It can be as big as the real thing's going to be, or it can be a smaller version. You just need to have a prototype so you can test it. This may be the most important step in the whole process. Engineers need to test their design to see if it works like they want it to. So, say if your building's a big tower, does it stand up? Does it stay standing up? If you're designing something with moving parts, does it work the way you want? Now take it from me, my future engineers. You might have a great idea, a really terrific solution to a really big problem. But when you get to this step, your prototype probably won't work exactly the way you want. At least, not on the first try. Most engineers test their prototypes over and over and over again. That's why a lot of time and brain power goes into the very last step: evaluating your solutions. Evaluating just means asking yourself whether things are working the way you want, or why they are, or aren't. I like to think of this step as question everything. This is when engineers review all of the facts and ask themselves questions, followed by even more questions. What worked well? Why did it work? Why didn't it work? How could it be made better? And most of the time, the answers to these questions are going to send you back several steps. Like, once you figured out why your prototype wasn't working, you'll have to design a new solution and then build it and then test it again. Sometimes engineers go through this process 4, 5, even 6 times or more. Take Willis Carrier, the inventor of modern air conditioning. He tested his prototypes for years before he figured out the design that worked the way he wanted and solved the problem he wanted to fix. Like all engineers, he failed a lot before he succeeded. And that's okay, because he learned something from every failure, which made his product even better in the end. And I, for one, am glad he kept going. So the engineering process is a series of steps that engineers, or anyone, should use when they're facing a challenge. The process is important because it allows engineers to experiment and also to fail. Both of these things give engineers a chance to go back and improve on their original idea, giving us something even better down the road. So the next time you fail at something, don't feel too bad. Think about the telephone and the air conditioner and the Eiffel Tower, and then try again.